Good. Hi, everyone. I'm Michael Casey. I'm the chairman of the Decentralized AI Society. We are a consortium, an association of projects and companies building at various layers of the stack that is needed to go into the rather complex array of challenges that Sreeram just lined out for us in terms of how do we get all this stuff to be fully verifiable at every level that we can trust. And that's sort of the mission that, in many respects, Decentralized AI Society is all about, bringing all these builders together so that we can collectively find a solution. And of course, when you do that, you inevitably find that not everybody agrees on the on the way forward. But that's the beauty of these sorts of forums, and then there's also the beauty of what we do. And what I'm a journalist by trade. I'm always about, like, we don't have the answers, but we let everybody come out and duke it out. So in the spirit of that, we're going to have a bit of a duke out. These guys are very polite. They're just generally nice. It'll be a very friendly boxing match. But I think it seems to me pretty clear the difference here. I want to start maybe with you, Sreeram, because that breakdown that you gave at the end there, where you talked about the framing of what is general intelligence, right? I think I saw Meredith Whittaker from Signal, right, just recently lay out just how dangerous this whole agentic conversation is that's happening in the mainstream, right? Oh yeah, we're moving to the agentic economy, and you'll have an agent that's going to be able to go into your calendar and book a time for you at an event, and then share that information with your friends, and then buy you the ticket, and so forth. And she just pointed out that agent's going to have access to your bank account, it's going to have access to your full list of friends, it's going to have access to your calendar, and we're just going to willingly give that over to that agent, right? This is nuts, but that's what the conversation is at. And so when you think about it from that level, it is incredibly complex to try to have protection and trust verifiability at every layer of that equation. So how's Eigenlayer solving for that? You worked it through there, but yours is a tokenomics. It's the beauty of the incentives. It's the beauty of the models around how we've run blockchains for some time. How do you take that and scale it into something as complex as an AI agent verification system?
This is an amazing question. So first, I think I'll lay out our thesis for what needs to be autonomous and what needs to be verifiable. And I think of three kinds of agents. Personal agents, like the example of an agent that's going to do booking and things for you. Is one kind of an agent. You can think of agents of the community, right? So it's agents that are built and owned by communities and collectives. And then you can think of agents that are fully sovereign. They're just operating on their own basis. And so you can think of what level of trust and verifiability and autonomy do you need, or sovereignty do you need for each of these things? A personal agent clearly doesn't need to be sovereign. It actually has to be subservient. That's part of the goal, is you want the agent to do what you ask it to do, not to do its own things. And so when you think about how much trust do you want to afford to these agents, I think there is a spectrum. And people are, because they're used to using software, going to be more trusting than they should be. But that's where we are, right? Like you're saying, the conversation is there that most people are just going to turn it on and see what happens. But when you think about the trust afforded to these agents on a personal one, you will have a full trust, at least several categories of fully trust me bro agents that people are going to take it on their face value. But when you go through these other levels, when you have an agent of a community, when you have an agent of a collective, when you have an agent that is fully sovereign, they don't have anybody to trust. If you think of the sovereign agent as the most extreme one, they can't trust anybody because, somebody will say, I ran your code, and then give them an answer and ask them to go buy a shitcoin, and then they lost all their money. So this is really important, in the verifiability stack. But another point I want to make is you can have two kinds of verifiability. One is a verifiability of the entire stack, which is what I laid out. It's a very high bar. It's extremely difficult. There is another way you can do this, which is outcome verifiability. So you say, I don't know what you do, but your outputs, let's say I ask it to go buy a ticket from SFO to SEA, and it thinks, SEA is Southeast Asia and just brought a ticket to me to Jakarta or something. And so that would be like a problem, right? But what you want is output verifiability. That might work for a whole bunch of use cases where you say, I don't care how you got to the outcomes. Just like for most humans, we don't know what they're thinking. We can only see what they do. And so the full stack verifiability is an insane high bar. There is output verifiability, which is to say, and one of the ways I think this is going to work out in the short term is insured agents. An agent will come and say, hey, I'm going to do what I say I do, like in English. And if it doesn't do that, or if it violates some of the covenants, you can raise an appeal and then like slash their money and take their money out. And so this is going to be a very lucrative model. I think just like when the internet started, one of the hardest things to do was how do you get people to put in their money or credit card or whatever online? And PayPal had to go through this, like, how do you get underwrite risk and so on. I think there'll be a similar phase transition into agents. I think where insurance can play a big role. So that's my like big picture.
So you're sort of thinking of the smart contract driven slashing and regulatory framework almost as a decentralized insurer. In this case, you're insuring the user, right? And the way that the cost is borne is by slashing the bad actor. Okay. Okay. So again, this is therefore you're going to have all these verifying nodes all competing to be the verifier in this case. Is it a sort of an incentive where everyone's like trying to win the next block, or how do you get the coordination of that network to work?
Yeah. So in our general like the paradigm, the idea is that in the normal mode, a single node or a few nodes might run each computation because everybody running all the computation is non-scalable and not going to get to like the infinite scale that we want. Maybe one node runs each computation, but they stake to promise that they're running that computation correctly. They publish the data in an open accessible repository. We have a network called EigenDA to do that. And then anybody who thinks it was run maliciously can raise a challenge. Then once a challenge is raised, they have to pay a cost for the challenge. That forces everybody to re-execute all the AI code. And then as long as the whole system is deterministic, then they will get the same answer and then they can slash them. So that's the whole pipeline.
So Illia, what's the problem with that? Now you're going to get a chance. You're going to have a chance to say the exact same. Don't worry, you're not going to get off that lightly, Illia. You're going to go back to Sreeram in a second. He's going to get after you. But yes, why have you gone down the hardware approach with the TE?
Yeah. So there's effectively kind of through the whole stack you just described of what's going to happen. There's some challenge with that, right? One is if you're trying to book a ticket from SFO to Seattle, you probably don't want everybody in the world to know about that. So you don't want the agent to publish about that right away. And so one of the biggest challenges with kind of crypto economic approach is the privacy, right? How do you actually deal with confidentiality? And I would like even up level it. One of the biggest challenges right now in AI itself, not in Web3, is actually a trust issue. The trust issue that as a model provider, I don't actually trust external compute providers, right? And I don't trust them with my model weights, which are extremely valuable. And so like I'm developing, the state-of-the-art model to do whatever, deepfake detection. As soon as you publish the weights for that, everybody will figure out how to cheat with it, right? So there's a whole kind of set of problems around that. I mean, I'm also at training time with data, there's all kinds of problems, right? So the confidentiality is extremely important for model providers, for user data, for enterprises, and for me just using it and, not everybody knowing where I'm going. I just ordered an Uber to this permissionless, right? Now, the second one is the fisherman problem, right? This is the reason why, for example, Near Protocol stopped using fishermen, even though that was like our original design, is because expecting that somebody there is monitoring some other computation and is like, let me double check that this is correct. Like it's also really hard expectation, right? You kind of need to incentivize them as well, which now you need like a probabilistic model. And it is solvable, but it adds even more and more cost and complexity to the system. Finally, you mentioned deterministic execution, right? Well, that's even harder problem in AI between the fact that computations, like LLM computation itself, is usually not very deterministic because of the different implementation hardware. to the fact that like when you're booking SFO to Seattle, if you book it, today versus tomorrow, they're probably going to be different price or different some other inputs and outputs. And so like realistically, even the re-execution of data may actually change within that shift. So that's why, I mean, we taking a different trade-off, right? We are expecting the hardware providers to not to be malicious, and you can still obviously address a lot of challenges with TEs being broken, etc. But at least confidentiality and a lot of the verifiability can be based on that, and you also get really interesting property that only this computation was done on your data, which you don't get even from ZK. So there's kind of a lot of interesting, just valuable like outcomes you get from using this framework.
Yeah, so it sounds like the critique, therefore, of the open network-based approach here is the cost of the computation, the idea of publishing information. How do you actually ensure privacy? What's your rebuttal to that?
This is super useful to lay these three things out: privacy, watching, and determinism. Okay, how do we handle these things? I mean, I'm going to spoil the suspense at the end. Like, there are use cases where this is better and use cases where that's better. But I want to explain what sets of use cases, what I'm saying is actually really better. But first, I want to address these three issues. Privacy. How do we deal with privacy when you have a crypto economic model? So think of booking the air ticket. And what I'm laying out is not like one specific way of solving all problems, but a category of ways of solving these problems. So, for example, booking a ticket. So I'm booking a ticket. Here is an agent. The agent promises that it'll only do what it says it does, right? Like not spend my money on other frivolous activities or book a wrong ticket. So that's what the agent has made a promise on, and that's what I'm taking an insurance against. And I go and like subscribe to the agent. And to do this thing, actually, I don't need to break my privacy other than when I challenge. Because it's 1:1, it's me booking a ticket. I know that the agent at the end like failed its criteria. And then what I do is I take the signed receipts that I have with the agent and say, oh, this agent didn't do like what it's supposed to do, and then go raise an appeal. So privacy can be solved in these 1:1 or an agent to a human scenario, but on challenge, you're losing the privacy.
How do you know that agent itself is not leaking all your data somewhere?
Oh, that agent itself is not leaking your data somewhere. That is not being protected by this model. You are nominally assuming that they're not, but you don't need to assume that all the time the data is published. So it's a different trust model. The second one, so that's the privacy angle. The second one is watchers. Actually, I was thinking a lot about this watcher problem. So to make the problem understandable for everybody, one node runs the computation, and anybody who doesn't like the answer can go and challenge it. And then like everybody runs the computation. But then like Illia's question, and he thought a lot about this because in building Near, this was one of the core ideas. They called it fisherman. A fisherman is somebody looking for something smelling wrong, and then go and actually like raise a challenge if something has gone wrong. So we call it watchtowers, the same thing. But how do we get watchers or watchtowers? And so one insight that we had is if you look at our existing financial system, this happens all the time. This is one of the reasons we take like 3-day settlement or 7-day settlement is you have all kinds of systems run to do anomaly detection and like other things not going right. And you don't, in fact, one of the things nobody does is to do full re-execution. They only do like heuristics or like analytics or like look at the consequences of these actions. Why is it looking like Sreeram suddenly spending from a country he's never been in? So that gets flagged, right? So, and we get calls and alerts and things like that. So people dig in and then go to the next level. So in the same way, you can have watchers and watchtowers which don't do full re-execution all the time. They are watching for effects of the actions of these agents and then triggering consequences. This is in scenarios where the agent's running not for an individual, but for a community. Because if an agent is running for an individual, you will know that you lost your money, so that you can obviously be in a locus to go complain. So you are your own fisherman. The last problem is the determinism problem. And how do you get these systems to be deterministic? And if you take the whole supply chain, there are all kinds of places where determinism might break down. But let's start with the one core thing that powers like a whole bunch of AI is inference, right? So you need to run inference deterministically. And this is a problem we've been thinking a lot about. And one of the hard things about inference determinism, so I have this meme, like you can think of like, is AI deterministic? And the left curve answer is, of course it's not. Every time I ask ChatGPT, I get a different answer. And then the mid curve answer is, no, you just set the seed and then you will get the same answer. But actually the right curve answer is if you go dig deeper, then you find, there's all kinds of shit that happens inside the tensor core kernel or whatever, where like you have ordering non-determinism, you have floating point non-associativity, all kinds of crazy things happen inside that make it non-deterministic. So getting inference, even just inference, deterministic, is a tall order. But one of our core breakthroughs with EigenCloud and why I'm kind of confident with the whole AI story is it's much easier to solve for hardware-specific determinism than it is to solve for cross-platform, cross-hardware determinism. I'll explain what it means. You think of, I want to run a computation or an inference on a H100 GPU. And it's easier to make this deterministic across H100s than it is to make it deterministic across H100 and a A100 and a M4 GPU and so on, and a tensor processing unit. That's much harder. But for EigenCloud, basically anything that you can get nodes to have access to, and if we said everybody's executing on H100s, the verifier nodes also need to have access to H100s, we're okay to make that trade-off. In fact, when you look at Bitcoin or Ethereum versus Solana, one of the kind of like ideological things that Solana broke was they said, Ethereum is very obsessed about home stakers. I'm going to give no shit about home stakers. And Solana's like, okay, run it on a data center or some big computer. What we are saying is you have access to elastic computation and GPUs on demand. So that's what is the higher requirements that we place that helps us solve this problem.
Okay, I want to get Illia he doesn't get off lightly here. In some respects, you're describing a model and approach I think is traditionally more consistent with the blockchain, crypto decentralized way of approaching it. Illia, to simplify, I think the critique of the hardware specific is now obviously you're now trusting that hardware itself, right? And I think in some respects, if you look at, you just mentioned, A100s, H100s, right? They're all made by the same company, right? We have a massive economic concentration in the chip world around one company right now. And so how do you avoid the fact that regardless of whether you feel like you can trust Jensen Huang or not, how do you separate that dependency, and how do we actually also get away from the sheer massive gatekeeping power that we're giving to that company, to these chip makers, by building things around their machines?
Yeah, so the secure enclave technology, right, has, 20 years of history, if not longer. And kind of historically, it's been highly underutilized because it's been really hard to use it. It's been really hard to implement. So Intel had this mode called SGX for, 10, 15 years. And it's been really hard to use it. You kind of needed to program as low level. They didn't have parallelizable instructions. So it was kind of a nightmare. And there was only few projects that were able to use it, and they never actually got to a level of scale. Now, what happened about a year ago, effectively, Intel came up with a new approach which allows to run effectively any virtual image, any kind of virtual operating system. So you can just run regular code without needing to re-implement everything. In parallel, AMD and ARM also have this option. So now there's actually 3 manufacturers on the CPU side. On GPU, on kind of hardware accelerator side, we only have right now indeed NVIDIA that offers this in H100s and B100s, 200s. But I have talked to a few other manufacturers, some of the upstarts. We also have RISC-V accelerators coming, which is something that crypto ecosystem is using heavily now. So they are looking into enabling this mode. I actually think that in coming years, probably, hard to predict, but like 1-2 years, we're actually gonna probably shift to all of the computation will be happening inside TE. Anthropic actually just published yesterday that they're looking into TEs. I know some of the other companies, obviously Google Cloud, we talked to Azure Cloud, they all have TE mode as well. Amazon has Nitro, and they're looking at. The problem with all of those clouds is that they don't actually give you the full provenance. So they have the key management system, and you effectively need to trust their key management system to provide you with a verification. Versus kind of where in blockchain, we solve that problem by the fact that we have blockchain to do key management. So this is effectively the both opportunity and innovation is you can have full provenance. You can validate that, like, hey, if I rebuild this Docker container, I can run it on this device and then get this certification, and it's correct. And the blockchain is the root of trust, right? So you use blockchain as a way to kind of have this interactive verification. But also you can now expand this to not only support one manufacturer, but support multiple manufacturers, and you can have a governance process that effectively authorize new ones. And then as this is becoming more prevalent, we should be investing, and there's like few different open source secure enclave projects to actually develop this, technology. And, if crypto is really actually invest in something, we can actually develop, at least probably not 1 nanometer or 2 nanometer, but like 5-7 nanometer is actually pretty possible.
I feel there's a potential hybrid between both of these approaches, right? I mean, you're bringing in a blockchain mechanism there to ensure that you are having sort of cross-device and cross-manufacturer verifiability. Because when you first started speaking, I started thinking a little bit about a conference I was at in Washington recently, which was basically the intelligence community decided to have an AI geopolitical conference in the midst of this huge battle, an argument over tariffs with China. And everything is all about, okay, how do we, what is our policy on chips, and how do we, what can we, the Taiwan relation comes in, it becomes very geopolitical. And of course, in the midst of all that is the expectation, I would think, that these hugely powerful governments are going to demand backdoors at some point to this very important technology, right? So that, of course, is just a reality of the world we live in. How secure, Illia, can we be in the idea that these models are not going to be somehow vulnerable to a state actor demanding that sort of access? And if not, does the sort of like this idea you had of multiple manufacturers give you that other layer of protection against that?
Yeah, I think like if we're really serious about geopolitical, similarly what happened to Bitcoin, right? You effectively incentivize creation of accelerators. And there's a whole industry, multiple different companies producing these accelerators. They all effectively comply to the same spec one way or another. And so I think we can actually, again, if we can shift away from like, hey, let's just give all of our data to one of these companies, to no, actually we want to protect our data, and the model providers actually want to provide it, and we have this network of kind of compute, like secure enclave compute, then this would actually generate enough investment to have like open source spec that multiple manufacturers can produce, and you actually have then potentially, like you can re-verify on different manufacturers for the critical needs to make sure there is no vulnerabilities there. I mean, there is things that we do agree, and there's a number of things where you do want to have an open version because it's community owned, and community owned should be like inspectable and verifiable, and so you can actually plug in indeed like T's plus cryptoeconomics for this kind of adjudication and verification type.
Yeah. So my synthesis, and before I say the synthesis, one thing that I think. So if you look at what the relative strengths of these two technologies, TE is privacy first, and is a big upgrade for anything you were already doing on the cloud at very negligible cost. I think that's not a small thing. It's a huge thing. So every single thing, every personal agent should really be running on a TE. Like this should become like base level for all of the internet and the cloud. But what I think is insufficient is the future that we are projecting, which is sovereign agents holding trillions of dollars. So am I going to trust a TEE to sign off on $1 trillion transaction for an AI agent? Absolutely no. Like I did this study, like I went to people and said, hey, if I say like the eigenlayer contracts, which hold $12 billion, instead of the eigenlayer being a smart contract on Ethereum, I just run it on a TEE. How much money will you stake into it? People who are staking hundreds of millions of dollars, they're like, maybe millions of dollars, not hundreds of millions of dollars. So there is just an order of magnitude difference, which is not just coming from the manufacturer scale risks. There is also operator scale risks, side channel attacks and other things that TEs have had various episodes of. So the synthesis is, if you start from crypto first and see like how to absorb more AI, you want to use the kind of thing that we are talking about.
Can I just interrupt for a second? I just think like maybe this is where you could imagine the debate being resolved, because why do we need sovereign agents with $1 trillion sitting in a wallet, right? Like, is it not a possibility that you could say, look, that's impossible because of the inherent risks associated with it, and therefore it doesn't get built? Because who is going to build a sovereign agent with $1 trillion? Eigenlayer are going to maybe, but it's got $1 trillion in its wallet. Well, it may not be a world that we need or want.
It's probably going to start with $1 million, and that $1 million, as we in
This is
crypto
gonna
know, may become $1 billion.
$1 million.
Yeah, in some sense, I think of like, why would an AI? I mean, people just assuming that an AI is going to continue to work for us, and I already feel like I've been displaced.
Well, they're already not working for us.
Yeah, so I'm not sure there is even
Sreeram is working for AI, and that's it.
So
bootloader for AI.
So anyway, look, I think it's an unresolved. We'll see how it all plays out. Basically,
I mean, we do actually have a couple autonomous agents running on Near. One of them is using effectively sentiment to trade assets. So it's sentiment on Twitter to decide to trade assets. It only had 10K, but it made 40% up in 2 months. But the interesting thing is that model is where we have, I call it brain inside TE, and I call it muscle on chain.
Yep.
And so the muscle verifies that, the brain doesn't do anything stupid.
Yep.
Right. So you can have a lot of enforcement on the smart contract level where like, hey, you probably shouldn't move in single thing, $1 trillion. And you can have a lot of effectively restrictions or systematic validation there. And then in parallel, we work on formal verification, so we can actually also add additional restrictions and requirements around how you can execute or what you can execute on there.
All right, we have to wrap there, I'm afraid. A round of applause for these gentlemen who very politely fought with each other.
Thank you so much.
Thank you.